Point 3, we're going to be graphing radical functions. So our favorite things put together, graphing and radicals. Yay. So we have two types of radical functions that we're going to be graphing. We have square roots. So square roots are just the square root with no index, just the square root of x. And then we'll have cube roots too. Our square root graph looks like this. It is always this shape. And then our domain we talk about the x values. It's when x is greater than or equal to 0. So we would write it as from 0 to infinity. And then our range is the same thing, but range is talking about y values. And we would write it as 0 to infinity. Now this is our parent function. So we could have transformations applied to our parent function to where our domain and range would shift also. So if our graph shifts, the domain and range would possibly shift. Bless you. Our cubed root functions are when we have the 3 as our index, so the cubed root, we're looking at the cubed root of x. So those graphs have this shape. So it's kind of like the same shape as the square root, but it also has that negative part too, because we can have negatives under cube roots, but we can't have negatives under a square root. And then our domain and range, anytime we have a cubed root, anytime our index is 3, our domain is and range is all real numbers. So you can say all real numbers, you could say ARN for all real numbers. Or you could say from negative infinity to positive infinity, or you could draw the R with the 2 lines. So all of these mean the same thing. You can write it however you want. All real numbers, ARN, negative infinity to positive infinity, or our all real numbers symbol here. The most important parts are the shapes of our graphs. It's like an R, but with 2 bars. So it's just the symbol for all real numbers. So we can graph 2 different ways. The first couple examples, we're going to graph one way, and then the rest will graph another. So we can graph by plugging in values. So we plug in numbers for x and get points, we can say. The second way we're going to graph is to use the transformations. But we'll do that in the last couple examples. So for now, we're going to be plugging in numbers for x and getting our points. So I'm going to make a chart here. I'm going to plug in values for x, get values for y, and then I'll have my point x, y. So I'm graphing the square root of 1/4 times x. What do you think a good number to plug into x would be here? 0. Awesome. 0. So I have the square root of 1/4 times 0. What's 1/4 times 0? 0. And what's the square root of 0? 0. So I plugged in 0 and got 0. So my first point is going to be at 0, 0. What do you think another good points plug-in would be? 1. So let's plug in 1. We have the square root of 1/4 times 1, which would be the square root of 1/4. So for this question, you could just plug it into the calculator, but we also could evaluate this. What's the square root of 1/4? So remember, it's like saying the square root of 1 over the square root of 4. What's the square root of 1? 1. And what's the square root of 4? 2. So it'd be 1/2. So when I plugged in 1, I got 1/2. Again, I will let you guys use the calculator so you could just plug that into the calculator. Practice using your calculator for the homework if you want to, and for the notes, just so you know how to use your calculator. But again, you could ask me any questions that you have if you're not sure. So go to the right one and up 1/2. Now let's think about it. I'm plugging in a number into the x, and I'm multiplying it by 1/4. So what do you think another good number to plug in would be? 2 would be okay, especially if we have a calculator, but what's a good number to multiply by 1/4? 4. Because what's 4 times 1/4? 1. Perfect. So let's plug in 4. So 4 times 1/4 would be 1. And what's the square root of 1? 1. So I plugged in 4 and got 1. So I'm going to go to the right 4 and up 1. Once you have 3 points, you can draw your graph. Just connect the points and your graph is going to have that shape, that just curved shape that we saw on the first slide. And we also have to identify our domain and range. So for the domain, we're talking about x values. So our x values go from left to right.
Pardon the interruption, Olivia.
So we always start at the left, start at your smallest x values. So this is my x-axis. We start at the left and work our way to the right. So if I'm starting at the left over here, what's the first x value my graph hits? 0. So my domain would start at 0, and then my graph keeps going forever in the right direction. So it keeps going to what? To infinity. So it'd be 0 to infinity, because it's infinity over here. So the graph starts at 0 and goes to infinity. Now for our range, we're doing the same thing, but we're looking at the y values. So that we go up and down. I guess we could say down to up, because we start at the smaller numbers first. So start down low. What's the first y value that my graph hits? 0. And then it goes up to what? It goes higher than 1, because we could plug in like 100 into x, and the square root of 100 would be 10, but we can plug in bigger numbers too. So we have like no bound, so it would be infinity. Now for domain and range, the infinity always gets the parentheses. And then we also want to keep in mind for domain and range, it goes from smallest to largest. So the numbers here go from smallest to largest. We always list it in order. So 0 is smaller than infinity, so we put the 0 first. So in this one again, we're going to graph by plugging in values. So I'm going to make my chart just like I did on the last one. I'm plugging in values for x, getting values for y, and then that would be my point xy. So here I have the cubed root graph. My index is 3. So the difference is when you have the cubed root, our graph goes from negative infinity to positive infinity. It's shaped like this. It's like both sides of it. It's not just the positive direction. So our cubed root graph shaped like this, and we can have negative numbers. Where we had the square root, we can't have negatives. So we just got to keep that in mind. What do you think a good number to plug in here would be? 0. Start with 0. So negative 3 times the cubed root of 0. Well, what's the cubed root of 0? 0. And negative 3 times 0? 0. So my first point is 0, 0. What's another good number? 1. So let's plug in 1. I have negative 3 times the cubed root of 1. What's the cubed root of 1? 1. And negative 3 times 1 would be negative 3. So here I have 1 comma negative 3 as my next point. Let's go to the right one and down 3. What's another good number I could plug in? So we're taking the cubed root of something. Now you guys do have your calculator, so you could put this in the calculator and figure out what the cubed root of 3 is, but it's going to be a decimal. What's a number that I know that I could take the cubed root of and get a whole number? 8. 8 is a perfect cubed. What's the cubed root of 8? 2. So good numbers when you have the cubed root would be like 1. Cubed root of 1 is 1. Cubed root of 8 would be 2. So these are perfect cubes. So we plug in perfect cubes. Let's plug in 8. So negative 3 times the cubed root of 8. What did we say the cubed root of 8 is? 2. And negative 3 times 2 is? Negative 6. So my point would be 8 comma negative 6. So it's a little bit off our graph, but that's fine. We're just using it to help us tell the shape. So I go to the right 8 and down negative 6. So it'd be over here. So that's part of my graph. But what did we say that we can have here? Negative numbers. So what else should I try to plug in? Let's plug in negative 1. So I have negative 3 times the cubed root of negative 1. What is the cubed root of negative 1? Negative 1. Awesome. So negative 3 times negative 1 is positive 3. So my point would be negative 1 comma 3. So let's put that on our graph. We go to the left one and up 3. What's another good point I could plug in? Just think about it. Our graph's going to mirror each other. Negative 8. Perfect, because I plugged in positive 8. So let's plug in negative 8. So I have negative 3 times the cubed root of negative 8. What's the cubed root of negative 8? Negative 2. And negative 3 times negative 2? Positive 6. So my last point would be negative 8 comma 6. So you go to the left to negative 8 and up 6. So our graph looks like that. So it's that same shape of the parent graph that we had in the beginning, which was like this. That was our parent graph. But we multiplied it by a negative 3. So we had a reflection happen. So that's why it flipped. So this is our parent. But it had a reflection, so it had to flip, which we'll talk about reflections on the next page. But notice how on the graph on the second slide, that box went in the different direction. It was up and to the right, but that's just because we multiplied by a negative here. Now let's talk about our domain and range. What do you think our domain is? All real numbers. Why is it all real numbers? Because it's the cubed root. Because our index was 3. So domain and range, when your index is 3, is all real numbers, always. So for cubed root graphs like this, you really only have to know what half of the graph is doing because the other half is just going to reflect the same thing. They're like mirror images of each other. But sometimes that could change when we have transformations happening. So let's talk about our transformations. So we've done transformations before when graphing parabolas. And I think we graphed absolute values too. These are the same transformations. We're just shifting our square root graphs, which look like that, or our cubed root graphs, which look like that. So we're just shifting these graphs. If we subtract on the inside, we move to the right. If we are adding on the inside, we move to the left. So one way we could think about it is left. Left has 2 plus signs here. So when it's plus on the inside, you move to the left. If you are adding or subtracting outside, that's a vertical transformation, so you move up or down. So adding on the outside, you move up. Subtracting on the outside, you move down. And then if you multiply by a negative, you have a reflection either on the x or the y. So if it's on the inside, it's on the y-axis. And if it's on the outside, it's on the x-axis. Remember, you want to keep your x's outside of the house. So if it's happening on the outside, it's reflection on the x-axis. For horizontal or vertical stretch or shrinks, we're going to skip these for now. We're not going to talk about the transformations of those. If you have one where you're multiplying by a number, either inside or outside, the best thing to do would be to plug in values to graph. So for these two, write it over here. Plug in values to graph, just like we did in the first two examples. When you're adding, or if you have a reflection, the best thing to do would just be to apply the transformation. Easiest way to graph it. So the first two examples looked like these, where we had to plug in numbers to graph. The next few will look like these, where we just apply the transformations. And you'll see the difference of like how we graph them. All right, so looking at example 2. We have to describe the transformation of f represented by g and then graph each function. So let's start by graphing our parent function, the square root of x. So this one is the parent. This is just our basic graph of the square root of x. So I'm going to plug in values here. Plug in values for x, get values for y, and we have our points x, y. What's a good number to plug in for x? 0. Can I have negative numbers when it's a square root? No. So let's plug in 0. What's the square root of 0? 0. So my first point would be 0, 0. What's another number I could plug in? Bless you. 1. We want to think of like what perfect squares are here. What's the square root of 1? 1. I'm going to go to the right one and up one. What's another number I could plug in? 4. Awesome. 4 is a perfect square. So what's the square root of 4? 2. So I plugged in 4 and got 2. So I'm going to go to the right 4 and up 2. So this is my parent graph here. Now it's super helpful to just know these 3 points for our parent function of x. Because once you just put those on your graph, we can just shift them, whatever our transformations are that are happening. So I'm going to make a note here. It's important to remember these. So these 3 points are important to remember. I said it's important to remember parent function points to apply transformations. That way you don't have to make this chart every time that you want to graph the parent function. Parent function of the square root is not going to change. It's always going to be these 3 key points. So just put them on the graph and then apply your transformations how it happens. So let's look at our g of x graph now. So we always start from the inside out. So starting with that -3 on the inside, what does that do to our graph? If we subtract 3 on the inside, which direction do we move? To the right 3. So I'm going to take my parent function and move it to the right 3. So all 3 of my key points here, I'm just shifting them to the right 3. So that pink graph was shifted to the right 3. I'm not done yet. We still have this +4. What does +4 do to our graph? On the outside, if I add 4, we move up 4. So I'm going to take these 3 points, the pink ones that I have now, and just shift them up 4. So it keeps that same shape as our original parent function. We just shifted it to the right 3 and up 4. But you don't have to do it in 2 separate steps, but if it helps you see how to move it, then move it. But you can just say, I'm going to the right 3 and up 4. So move each point to the right 3 and up 4. This point gets moved to the right 3 and up 4. This point gets moved to the right 3 and up 4. So our entire graph just gets shifted to the right 3 and up 4. Any questions on how we got this graph? Right, last thing, let's find the domain and range. So domain, we're talking about the x values. We always start from left to right. So starting at the left, where would my graph start? At what x value? 4. The red graph. Our red graph starts at 4. Or no, it's at 3. Yeah, because we shifted to the right 3. It's at 3. So 3. And it goes to what? If we keep moving to the right, it goes to infinity. And let's look at our range. So range is the y values. We go from the bottom to the top. So where does our graph start? At what y value? 4. So our range goes from 4, and then we keep going up. Where does our graph end? Infinity. All right, on the next slide. Again, I have a square root graph. So I'm going to start with my parent function and then just apply the transformations. What were the 3 important points that we need to know for our parent function of a square root? 0, 0, 1, 1, and 4, 2. So let's just start with these points and then we'll shift them. So anytime it's a square root, these are the parent points. So start with that and then we shift them. So looking at my g of x here, I'm adding 1 on the inside. So which direction do I move? I go to the left one. So I'm going to take all of my points and just shift them to the left one. So to the left one, to the left one, to the left one. Graph our line. Now let's talk about our domain and range. So that's it for the graph. That's all we had to do. Know our parent points, just shift it to the left one. You don't have to graph that blue line there if you don't want to. That's just to help us see what our original graph looks like, and we just apply the transformations to that. So our domain, we're talking about x values. So going from left to right, what x value does my graph start at? -1, perfect. So my domain starts at -1 and goes to what? Infinity. Then for my range, we're talking about y values. So start down low and go to the top. At what y value does my graph start? 0. So we start at 0 and go to infinity. Perfect. All right, for the last one, we want to describe the transformation of our parent cubed root function and then apply the transformations. So starting with our cubed root. So let's find our parent points. We only need to do this once because once we know our parent graph, then we're just going to shift it based off of that. So for the cubed root, can I have negative numbers? Yes. We can take the cubed root of a negative. So it's going to be this shape graph. So I'm going to plug in values for x, get values for y, and have my points x, y. What do you think a good number to plug in here would be? 0. So when I plug in 0, what's the cubed root of 0? 0. So my first point is 0, 0. What's another number I could plug in? 1. What's the cubed root of 1? 1. So 1, 1 is my next point. Go to the right 1 and up 1. What's another number I could plug in? 8. 8 is our perfect cube. So what's the cubed root of 8? 2. So my other point would be 8, 2. It's a little bit off our graph, but that's fine. We're going to go to the right 8 and up 2. Just helps us see the shape of our graph. So that's the right side. What else could I plug in? -1. What's the cubed root of -1? -1. So my other point's -1, -1. So I'm going to go to the left 1, down 1. And what's another point? -8. So I have the cubed root of -8, which is -2. So -8, comma -2. Just go to the left to -8 and down -2. Now this is our parent function. So again, you don't have to graph the parent function every time. Just know your important points. Yes. So these are our important points for our parent function. Now remember, it's a mirror of itself. So whatever happens on the right, the same thing's going to happen on the left. So as long as we know like these 3 points, just know that your graph is this shape. I'm not very good at drawing it without the graph, but it looks like that. So these are our important points. So our important cubed root points. So once we just put those on our graph, then we can apply the transformations. So let's look at our transformations now. And when we have more than one transformation, we always want to start on the inside and work out. So we start with what's happening directly to the x. So which transformation here do you want to apply first? Which one? The reflection on the x-axis, perfect. So we work from the inside out. So start with what's happening directly to the x. So that negative is a reflection on the x-axis. So x-axis is this one here. So that acts as my mirror. I'm reflecting it on that axis. So all my points above the x-axis now go below the x-axis. All the points below the x-axis go above. So I keep those same points, just flip them. So that's my first transformation, just the negative. also have this minus 2 on the outside. So what does that minus 2 do to our graph? Minus 2 on the outside, what does that do? We go down 2. So I'm going to take my green line there and just shift all my points down 2. So now this red graph is my graph of the g of x. If you want, erase all the other ones. Again, you don't have to draw it, but if it helps you see which way you're moving, especially when you have more than one transformation happening at a time, I think it's helpful to draw. So this blue one was our parent function. And the red one is our graph with the transformations applied, so with both transformations, the reflection and moving down 2. Last thing we want to do is identify our domain and range. What's our domain? What type of graph do we have here? Cubed root, so it is all real numbers. What's our range? All real numbers. Anytime it's a cubed root graph and you have this long squiggly line here, your domain and range is always all real numbers. One more thing to keep in mind, a little helpful hint for the homework. If you have x to the 1/2 power, that's the same thing as saying the square root of x. So that graph for x to the 1/2 power will be the same as the square root of x, our graph that's just half like that. If you have x to the 1/3 power, that is the cubed root of x. So that graph would be the whole one that looks like that. That goes in both directions. So these are the same thing. It just looks a little bit different, but it's no harder than what our original graphs of these two look. Nothing changes from these. It just is written differently.